Okay, today we are going to talk about the lesson preparation study guide for solving systems of equations algebraically. We're going to talk about substitution method and basically the elimination method and the different types and ways we can go about the elimination method. Okay, so we'll be doing this worksheet here, solving systems of equations algebraically. Example 1, and you end up with normal case, two lines are crossing each other. Substitution when there's not exactly one solution. So that could be a case where two lines graph on top of each other. So we'll also talk about the vocabulary that goes with this. And then on the flip side, we got an application problem with a mixture. So we're going to get two equations, and then we'll talk about the elimination method when there's one solution, when there are another method. Okay, so let's get started. So I'm going to use my notebook file for this. Let me bring this up. So here we have our notebook file, and we want to talk about this these steps here first. So let's talk about this. So if you want to use the substitution method, or if the problem is set up for the substitution method, then basically the trick is to get one of the equations that you have in this system into either y equals or x equals form, so you can substitute that into the other equation. So it's almost like a function composition type move. So let's see what we need to do with this one. Let me move this out of the way. So we want to use substitution to solve this system. So the method they want us to use is substitution. We've got 8x minus 3y is equal to a negative 1, and x plus 2y is equal to negative 12. So they're already telling us that we have one solution, which means that this is going to be a case we're expecting where one line is going to be crossed by the other line, and the x and the y that we're going to find is the coordinate of the intersection point. So let's look. So 8x minus 3y is equal to 1. Let me write that down. Equals a negative 1. Make sure you transcribe it correctly. And x plus 2y equals a negative 12. Now, in looking at this, I can see that I can easily get this second equation into x equals negative 2y minus 12 by subtracting 2y from both sides. So when necessary, solve at least one equation for one of the variables. So we have x is equal to minus 2y, it's a y, minus 12. And we are going to substitute that in for the x in the first equation. So we're going to have 8 times, and what x is equal to is negative 2y minus 12. And then that is going to be equal to what we have on the other side, which is minus 1. Oh, you still have minus 3y equals minus 1. So we have to simplify this. 8 times a negative 2y is negative 16y. 8 times a minus 12 is a minus 96. And then we have a minus 3y equals a minus 1. So we can collect like things on the left, like y's on the left and numbers on the right. So negative 16 take away 3 more is negative 19y's. Negative 19y's. And that's going to be equal to a negative 1, but we're adding 96 to the other side. And so we get a positive 95. 96 take away 1 is a 95. And 5 times 19 makes 95. So y is a negative 5. So we know that the y coordinate where these lines cross is negative 5. And we need to figure out what the x is. So back to one of our two original equations. Always try to go back as far as you can to the original when you do a substitution. I'm going to put a negative 5 in for this y in the second equation. We also could have used the first equation, but this one looks a little bit simpler. So we have x plus 2 times negative 5 and that's going to equal negative 12. So 2 times negative 5 is a negative 10. X plus a negative 10 equals a negative 12. Add 10 to both sides. X equals a negative 2. So negative 2. So these two lines are going to cross where x is a negative 2 and y is a negative 5. Now for the check, I could go into the other equation and kind of mentally see if it looks like my answer seems like it makes sense. So if x is a negative 2, I have 8 times a negative 2, that's going to be a negative 16, minus 3 times y, where y is a negative 5, which makes a negative 15. And take away a negative is the same as a positive, and I do end up with a negative 1, so it checks out. Okay, let's look at the next page. Now, here's an example of substitution when there may not be exactly one solution. Like they're kind of giving us a hint ahead of time. Normally we would have to go ahead and try to work this out. So let's see what we got. Now, this is already set up for substitution because one of these is in y equals form. So what we're going to do is substitute for this y what y is equal to, which is the 2x minus 11. So I'm just going to copy this down and I'm going to replace the y with 2x minus 11. So we have minus 5x plus 2.5 times y, but y is equal to 2x minus 11. And that's going to be equal to a negative 15. Have to distribute. 2.5 times 2 is 5, so we get 5x out of this part. We have a minus 5x over here already. And 2.5 times a minus 11 is going to be a minus 22 plus another 5.5, so minus 27.5. And that's going to equal negative 15. So pretty much what I did here was I just did twice the 11, which is 22, and half of 11 is 5.5. So 5.5 and 22 added together makes 27.5. Now what happens here is 5x and negative 5x cancels out. So basically you've got negative 27.5 equals a negative 15, which is not true. So you've got two lines here, but you've got two lines that don't cross. It has to be the case that these two lines are parallel to each other, because in the plane, parallel lines are lines that always stay the same distance apart and have no intersection points. So if we wanted to throw some vocabulary in on this, this is an inconsistent system because there is no solution. So it's an inconsistent system. If we look back at the one before, we get an answer that makes it consistent. And we only get one answer, so it makes it independent. So one solution we call the system, if we wanted to classify it, we call it consistent and independent. If there's no solution, it's an inconsistent system. Let's look at the next part. So for this part, they want us to apply the substitution method. So we have to dig some equations out of this. So hydrochloric acid solution, she needs 300 milliliters of a 5%. And she has a 3.5% solution and a 7% solution. So she needs 300 milliliters of a 5% solution. So let's see what they're doing here to write the equations. Together she needs 300 total milliliters of both solutions. So we get x plus y is equal to 300, where that's in milliliters. And the percent solution is 3.5% of, say, our x solution. Well, now as a decimal, you have to move the decimal 2 places to the left. That's a 0.035 x and plus 0.07 y. And that's going to equal the total in concentration that she needs, which is 5%, which is 0.05 times 300. So that's where the two equations come from. Now they want us to solve this using substitution. I can take this first equation and get it in x equals form by subtracting y from both sides. Or I can get it in y equals form by subtracting x from both sides. So I think what I'll do is get it in y equals form by taking x away from both sides. So y is equal to negative x plus 300. So that's what I get from the first equation, and that's going to get substituted into the second equation in place of the y. So we have 0.035x plus 0.07 times y, but y is minus x plus 300, and that's got to equal 0.05 times 300. So let's see what we get. So 0.07 times a negative x is going to be negative 0.07x. 0.07 times 300 is going to give us something to do with 2100. Let's see what we got. We got 2100 and we got 2 decimal places, so we get 21 out of that. And 0.05 times 300, that's going to give me 5 times 300 give me 1500. But we've got 2 decimal places, so we get 15 out of that. So we got the 0.035x plus 0.07x, or minus 0.07x, plus 0.07 times the 300 gives us 21, and that's got to be equal to 15. So let's see what we got here. Now these 2 decimals are different place value, different lengths in terms of place value. So we can add a 0 there at the end and look at this as a 70. So we have a 35, take away a 70, that's going to be a negative 0.035x. And we're going to take 21 away from both sides. We get a negative 6. And let's see, I'm going to try to avoid using the calculator. I'm going to multiply everything by 1,000 to get rid of this decimal. On the other side, multiply by 1,000. I get 6,000, negative 6,000. So x is going to be negative 6,000 divided by negative 35. Now 5 goes into both of those. It's going to go 1,200 times in the top. The two negatives are going to cancel out. And in the bottom, let's see, 5 goes into that 7 times. So we've got whatever 1,200 divided by 7 is. Let's see what we get. So we're here to the calculator. Let's see. We got, can't see very much of this. Turn the light on. Kick the light on here. So we got 1,200 divided by 7. Because that'd be 171.4. So we get 171.4. So now if x is 171.4, and together x and y have to add up to 300, then 300 take away 171 is going to be 28.6. So y is going to be 28.6. It's going to be 128.6. And if we check it out, we get 200 out of those, we get 99, and then we get the 1. So y is 128.6, and x is 171.4. So this fits the first equation. That's what I used to actually find the y part. We could double check it and run this through and see if we do get a true statement out of this. I'm not going to take the time to do that right now. But and this is in terms of milliliters, ml. Always, if you're given units, try to carry your units through. Okay, let's look at the next one. Now let's talk about the elimination method. Enlarge this. So in the elimination method, what you need to do is try to multiply. If you're not given a problem where your x coefficient or your y coefficients are opposite each other, so they would cancel out if you add them, you find the suitable multiplier or multipliers to make them opposite each other so they'll cancel out when you add. And then you basically end up having to, once you get an answer, you end up having to substitute and see what the other variable is. So let's check this one and see what we get. So we got this. So we can see where this minus 9 and this minus 9, if one of these was a positive, they would cancel out. So my plan on this will be to multiply the second equation by a negative 1, which will turn this into a positive 9. So when I add these together, they'll cancel out. So the best way to use the elimination method is to find multipliers that cause one pair of coefficients at least to be opposite each other. So let's look. I'm going to multiply the second one by a negative 1. So I'm just going to copy the first one down. Negative 2x minus 9y is equal to minus 25. For this other one, I'm going to make everything opposite because of the minus 1. So I get 4x plus 9y equals positive 23. Now these are set up so that if I add these two together, the y's are going to cancel out. A negative 2x with a positive 4x gives me a 2x. And a negative 25 with a 23 gives me a negative 2. Divide both sides by 2. X is a negative 1. So x is a negative 1. Now we have to find out what y is. We're going to take this negative 1 and go back to one of our two original equations. So I would go back to my first equation, which wasn't changed. It would work just as well if I went to this one, but it's best practice to always go to one of your original equations when you substitute back in. So if I go back up here, let's do it with the second one. I have a negative 4 times a negative 1, which is a positive 4. I have a minus 9y. So we have a, let me switch colors at the same time here. So we got a, I'm going to go up here with a negative 1. So negative 4 times a negative 1 is a plus 4. Minus 9y's equals minus 23. I'm going to take away 4 from both sides. Minus 9y's is equal to minus 27. And divide both sides by minus 9. Minus 27 divided by minus 9 is 3. So y is 3. So we have a system of lines that cross and intersect in one position, and that coordinate is x is 1, y is 3. X is negative 1, y is 3. So this is a consistent system because there is an answer. And it's an independent system because there's only one answer. Okay, let's look at the next one. With this example here, it says multiply both equations for using elimination. This is, pretty common. Have to do this. We have to multiply both equations to get the opposites that you need. So we get some choices here. Like I can see with the y's, the LCM of 5 and 4 is 20. If I wanted to go with my x's, the LCM of 2 and 3, least common multiple, is 6. So it doesn't really matter which one, but just to keep the number small, I'm going to go for canceling out the x's. They go with the 2's and the 3's. So when I look at this, get this out of the way. So again, we're going to go for canceling the x's just because the numbers will be a little bit smaller. So let's see. If I made this a positive 6 and this a negative 6, then they would be opposite. So I'm going to multiply the first equation by 3, and I'm going to multiply the second equation by negative 2. So this is all part of the planning to see what I need to do to get these opposite each other. So 3 times 2x is 6x. 3 times 5y is 15y. And 3 times 1 is 3. For the second equation, a negative 2 times 3x is negative 6x. A negative 2 times a negative 4 is a positive 8. That goes with y's. And a negative 2 times a negative 10 is a positive 20. So these are set up now so that when I add these together, the x's will be eliminated. With these I get 23 y's. And on the other side of the equals, 3 plus 20 makes 23. Therefore, y must equal 1. Now, if y equals 1, we need to see what x is. So we're going to take this 1, go to one of our two original equations, and plug it in for the y and see what x has to be. So if I go to the first one, we have 2x plus 5 times 1, where y is equal to 1 from this, is equal to 1. So 2x plus 5 equals 1. Take away 5 from both sides. 2x equals negative 4. Divide both sides by 2. X equals negative 2. These two lines are going to cross where x is equal to negative 2 and y is equal to 1. Now mentally I could check it in the second one to make sure that these are correct. 3 times a negative 2 is a negative 6. Oops. And minus 4 times 1 is a minus 4. And negative 6 take away 4, which is plus a negative 4, is the same as a negative 10, so it checks out. So here's a system, again, that is consistent because there is an answer, there is an overlap, and there's only one place, so it's consistent and independent. Okay, let's look at the next one. Elimination, where there's not exactly one solution. So let's see. So here I want to get my x's or my y's to cancel. The LCM of 6 and 18 is 18. The LCM of 21 and 7 is 21. So not much difference. I'm going to again go for canceling out the x's. So I'm going to multiply this second equation by negative 3, which will make this a negative 18x, and that's going to cancel that when I add it together. So that's what the plan is. Switch colors and get black. So we've got 18x plus 21y equals 14. And this second equation I'm going to multiply by a negative 3 to make the x's opposite. So I get negative 18x. A negative 3 times a 7 is a minus 21y. And a negative 3 times a 2 is a minus 6. So now when I add these together, my x's cancel. That was the plan. But also notice here, the y's end up opposite. They're going to cancel out also. And 14 with a negative 6 is going to give me a positive 8. So 0x, 0y, the same thing as a 0, equals 8, which can never be true. Therefore, there's no solution. Which means that this must be 2 parallel lines, just like in that first example that we did. Because if the lines don't cross, that's what they have to do to be other than skew lines, which we're talking about in the plane now. But theoretically, you could have skewed lines in like some kind of like a 3D space, like this, that would not intersect. But in the plane, we're talking about 2 lines that don't intersect, having no solution. This is an inconsistent case because there is no solution. So if there's a solution, it's consistent. If there's no solution, it's inconsistent. And there's one more case we need to talk about, and that's the case where the equations intersect every place. So let's look at one of these. Let's say we had 2x plus 3y is equal to 6. And let's say we had negative 4x minus 6y is equal to negative 12. Okay, so we got 2 equations here. And we want to solve this using elimination, or using any method. It would, it'd be a little bit, you could get it in y equals form, either one of these, but it's going to be some work. So elimination method might be the easiest. If I look at the x's here, I see that if I was to multiply this first one by a 2, this would make that a 4, and that would cancel out with a negative 4. So that's what the plan is going to be to do, to multiply the first equation by 2. And I'm going to just do that and then copy it in down here, then cross that one out. So 2 times 2x is 4x. 2 times 3y is 6y. Already I see there might be a problem here. And 2 times 6 is a 12. So let's add these up and see what we get. Negative 4x and 4x makes 0 x's. A negative 6y with a 6y makes 0 y's. And a negative 12 with a 12 makes 0 for the numbers. So 0x and 0y is the same thing as a 0, and we end up with 0 is equal to 0 for this one. Now this is a true statement. 0 is always going to be equal to 0. So that means that these 2 lines cross every place. The x's and the y's don't matter. These lines have infinitely many places of intersection. Now in the plane, The only way that that can happen is if one line is actually the same as the other line, or we view it as graphs onto the other line. So one line graphs onto the other line. This is a case where there is an intersection, so it's consistent. But there's not just one place of intersection. They intersect every place, so we call that dependent. P-E-N-D-E-N-T. So we call it a consistent dependent case. D-E-P-E-N-D-E-N-T. So with these systems, you can get an X and a Y answer that's consistent, independent. You can get a statement that doesn't make sense, like 0 is equal to 7, which can never happen. So that means that is inconsistent. Or you could get the case where, like we just saw here, where you get a true statement that's always true, like 0 is equal to 0. That's going to be consistent, but that we call that dependent. So one solution, many solutions. No solutions for those. Okay, so I hope this video helped. We talked about solving systems by substitution, and we talked about solving systems algebraically.